Good morning, students. Today we start with the next chapter, that is chapter number 6, Circles. Okay, in this we are going to study the basic concepts of circle and few theorems or the properties of the circle, which will be in a form of theorems. We have to prove it. So here we begin. Let's start. So, a plane is divided by a circle into three parts, namely the interior, exterior of the circle, and the circle itself. The chord is a line. Chord is a line, this green color line, okay, uh, passing from one point of to another on the circumference of the circle is known as chord. What is chord? A chord is a line passing from one point to another point on the circumference of the circle. Okay. Diameter is a chord that passes through the center. It is the largest chord of the circle. Right. A perpendicular drawn on the chord from the center bisects the chord. Similarly, the line is perpendicular if it is drawn from the center to bisect the chord. Okay. Only one circle can pass through three non-collinear points. Chords equal in length are equidistant from the center. Similarly, chords are equal if they are equidistant from the center. Angles subtended by the same line segments are equal if the chord of circle are equal in length. Then the corresponding arcs will be congruent. Similarly, if arcs are congruent, then the corresponding chords will also be equal. Okay. So here, observe the figure, that is a circle is given in which the blue line represents the secant, because the line intersecting at 2 points is known as secant. The line joining, it means touching the circle, is known as tangent. So it is represented by the red line. You can observe the figure. Okay. Then the line passing through the center, line segment passing through the center, is known as diameter. Half of the diameter is radius, and the line joining the any 2 point on the circle is known as chord. Diameter is the biggest chord. Okay. Now we move on to the next part of it. Here, congruent circles. Now the circles with the same radii are known as congruent circles. The circle with the same radii are known as congruent circles. Suppose the two circles are drawn with the radius 5 centimeter, then the two circles are said to be congruent. The next one is concentric circle. This one is concentric circle. Okay. Now what is concentric circle? The circle with the same center but different radii is known as concentric circle. A circle with same center and different radius. Okay, that circle is known as concentric circles. Now we will talk about the touching circles. Now the circle may touch internally, here this figure, or the circle may touch externally, this figure. Okay. Now in both the cases, uh, these two cases are of touching circles, right? One is touching internally and the other one is touching externally. Now both are touching each other at one single point, means the one when the circle touches each other, they touch at one single point. But when the circle intersect each other, they intersect at two distinct points. Okay. This is the basic difference between touching circle and intersecting circles. I hope I am clear. Now we move on to the next part. Yeah. Now very first property of the circle, perpendicular from the center of the circle to a chord bisects the chord. Now here the perpendicular drawn from the center of the circle to the chord. This is given part, right? Bisects the chord is the part that we have to prove. Now here we begin with the proof. This is the first property of the circle. So we begin with the proof. Now we have been given the circle with center O, in which AB is the chord, right? And such that uh, OM is perpendicular to AB. This OM is perpendicular to AB. Now we have to prove that OM bisects AB, means AM is equal to MB. This we have to prove, right? Now, due to OM, the full triangle is divided into two triangles, right? Now here we have to prove that the two triangles are congruent. So which are the two triangles? Triangle AMO, triangle AMO, and triangle BMO, BMO, right? Now here what is given to us? By observation you can see that OA, this OA is equal to OB, right? OA is equal to OB. Why they are equal? Because they are radii of same circle. Then OM is common. This is by construction. This OM is common in both, right? And one of the angles so formed over here at point M is 90 degree. Here at point M is 90 degree. Okay, so the two triangles will be congruent by which test? By hypotenuse side test. Okay, so by hypotenuse side test, the two triangles are congruent. As two triangles are congruent, then their each side will be congruent to one another. So AM is equal to BM, right? Corresponding sides of congruent triangle. So from here we prove that the perpendicular drawn from the center of the circle to the chord bisects the chord. I hope I'm clear. Now we move on to the next part. Now in next, okay, so here we begin with the first problem of the exercise 6.1. Now distance of the chord AB from the center of the circle is 8. Length of chord AB is 12. Find the diameter of the circle. Okay. Now here let O be the center of the circle. This O is the center of the circle. AB is given to us as 12. OC is given to us as 8. Okay, and OC is perpendicular to AB. Now we know that the perpendicular drawn from the center to the chord bisects this chord. Okay, so length of AC will be equal to 6. So in triangle OCA, OC square plus this OC square plus AC square is equal to AO square. So 8 square plus 6 square is equal to AO square. So what will be AO square? That will be equal to 6 square is 36 and 8 square is 64. 64 plus 36 gives us 100. Now AO square is 100. So what will be AO? It will be equal to 10. Thus AO is equal to 10 centimeter. Now diameter we have to find out. So diameter means AO is the radius. Now double of the radius will give us the diameter. So 2 into 10 gives us 20 centimeter. So the diameter of the circle is 20 centimeter. Now the next problem. That is problem number 2. The diameter of the circle is 26 centimeter and the length of the chord of the circle is 24 centimeter. Find the distance of the chord from the center. Diameter is equal to 26. Chord is 24. Now diameter is 26. and chord is, this AC is the diameter and chord is AB. Okay, so AC is 26 and AB is 24. Okay, now we all know that the perpendicular drawn from the center of the circle to the chord bisects the chord, right? So if I draw a line from the center to the chord, it will be perpendicular to the chord. Okay, so OD, this OD is perpendicular to AB. Okay, now as it is perpendicular, it will bisect the chord into two equal parts. So as AB is 24, half of 24 will be equal to 12, right? Now I will consider the triangle over there. So that triangle is triangle AOD. Okay, so here we have to find out OD now. What we have to find out? OD. So OD square plus AD square is equal to AO square, right? Now AO will also be half of 26. So half of 26 is 13. So here, substitute the values. OD square plus 12 square is equal to 13 square. Now OD square is plus 144 is equal to 169. So this 144 will come to 169, will come to right hand side. So it will be OD square is equal to 169 minus 144, that is equal to 25. So OD square is 25. So OD will be equal to 5 centimeter. So the distance of the chord from the center is 5 centimeter. I hope this problem is clear to you. We'll move on to the next problem now. So the next problem is, the radius of the circle is 34 centimeter. Okay, the radius of the circle is 34 centimeter and the distance of the chord from the center is 30 centimeter. Find the length of the chord. We are supposed to find the length of the chord. Now distance is given to us from the center to the chord, that is 30 centimeter, and the radius of the circle is given to us as 34 centimeter. Okay, so we have to apply the theorem over here. Okay, and Pythagoras theorem. So by Pythagoras theorem, first we have to find out AC. So length of AC is to be calculated as AC will be what? It will be equal to AO square minus OC square. Okay, AO square is 34 square minus 30 square. So 34 square is 1156, right? Now and 30 square will be 900. So 900, 1156 minus 900 will give us AC square. So AC square is equal to 256, right? So AC will be equal to 16 centimeter, and AB is double of AC as perpendicular drawn from the center of the circle to the chord bisects the chord. So AC, half of it is 16. So double of that will be 32. So length of AB is 32. I hope I'm clear. So here we move on to the next problem now. Problem number 4. The radius of the circle with center O is 41 unit. Length of chord is PQ. Length of chord PQ is 80 units. Find the distance of the chord from the center of the circle. Okay. We know that the perpendicular drawn from the center of the circle to the chord bisects the chord. So PR is equal to RQ. This PR is equal to RQ and is equal to 40 centimeter or 40 units, right? So in triangle OPR, OR square plus PR square is equal to OP square by Pythagoras theorem. Substitute the value to get the value of OR. So the value of OR I am getting as equal to 9 units. So the distance of the chord from the center of the circle is 9 unit. Okay, now we move on to the next part of it, the last problem. In this problem, we have been given a circle concentric circle, and we are supposed to prove that AP is equal to QB. This is what is the figure that we have drawn over here. What we have to do is we have to draw the perpendicular to the chord AB. After drawing a perpendicular to the chord AB, it will be perpendicular to OC also, PQ also, interior circle PQ, okay, and exterior circle chord is AB. Now here, as we know that the chord, the line segment or the perpendicular drawn from the center of the circle to the chord bisects the chord, right? So here PC square will be equal to CQ square, okay? And sorry, PC is equal to CQ, so AC is equal to CB, right? Now when I subtract this, AC minus PC is equal to CB minus CQ, so AP is equal to BQ. This is what is the proof. I hope it is clear. So here we end up with the first exercise. Thank you.